Welcome back, dear students. As you know, we were discussing the paper from May-June 2023, and so far we discussed two questions of the same paper. So today we are proceeding with the solution of and the discussion of question 3 of the same paper. So without wasting any minute, I'm proceeding towards question 3 of the same exam paper here and trying to discuss it completely so that you satisfy and you may learn properly, not only how to answer, to understand what are the concepts involved in these questions, or in specifically question 3. Here he says that figure 3.1, which is this figure, giving us a synthetic root. Okay, she says that describe a sequence of reactions that can be used to produce food additive, the compound Y, from chloroethane. So chloroethane is what? Halogenoalkane. So if we just consider what is happening in this, what we can say the synthetic root, quickly I'm going to discuss. It will help a lot to answer all the relevant question in the preceding parts. So first of all, if you see what is happening here, the chloroethane undergoing a step 1, converting into how many? This is nitrile, due to the presence of CN or nitrogen in the chain of the carbon. We say it is alkane nitrile. But how many carbons we have here? 1, 2, 3. So this is propane nitrile. This is what? Propane, due to these 3 carbon atoms, and as between carbon to carbon single bond, so it is ane, and the ending will be with the nitrile. So I'm writing here as nitrile. So how the halogenoalkane converted into propane or any alkane nitrile? This could be done by adding potassium cyanate that is dissolved in ethanol. Okay, and additionally we are providing it heat, or you can write heat under reflux, HUR. If you are writing just heat, fine enough, but if you write heat under reflux, I think more better. Okay, so by the reaction of this, the chloroethane with KCN dissolved in ethanol, or you can write alcoholic KCN in heating or heat under reflux, we will get the X, which is propane nitrile. Then next step is that the propane nitrile is converted into propanoic acid. This is what? This is propanoic acid. So what we can say that how any alkane nitrile converted into propanoic acid? By the addition of acid. This is hydrolysis. This is what? Hydrolysis. So, and as this is happening in the presence of the acid, I can say this is acid hydrolysis. Okay, so next step, the propanoic acid is reacting with the metal calcium, producing Y. So it could be what? Calcium propanoate. We will get what? Calcium propanoate. We may write the equation if demanded. Okay, so this is the sequence I consider to discuss all these steps in detail so that we can easily solve the relevant questions. Now proceeding with the solution of the direct demands which examiner is asking in your question paper. In first, he says that state the reagent and condition. As I write it clearly, it is what? Potassium cyanate dissolve in ethanol and heat or heat under reflux. Second part, he says give the synthetic name of X. So synthetic name of X is propane nitrile. We write it already. Then in third, he says identify the type of reaction that occurs when dilute acid is added to X in step 2. So he says that type of reaction, and we answered it as well while discussing the synthetic route. It was acid hydrolysis. Then in step 3 it says Y and a gas are produced. Now you have to write an equation. So now I am going to answer or writing answer each one of you, each one for you, so that you can easily understand. Although we discussed, but right now I am going to write down what are the correct answers. Here you can say that potassium cyanate in the form of formula, you can say dissolve in ethanol. Even you can write alcohol, but more specifically better that you have to write ethanol. Then you have to write heat under reflux, or just write heat under reflux, or as I said, you may write just heat, enough, it is acceptable. Then give the synthetic name of X. We discussed the name of X was propane nitrile. Propane nitrile. Then identify the type. We also already discussed that what hydrolysis, and that was taking place in presence of the acid. So I can say it is acid hydrolysis. Acid hydrolysis. Finally, we have to construct the equation in reaction in step 3 for the formation of Y and a gas. So we know it was propanoic acid CH3 CH2 COOH. This is propanoic acid reacting with the calcium, giving us CH3 CH2 COO whole twice, because the calcium has a charge of 2 plus, whereas what we can say propanoate ion has a 1 negative charge, giving us the situation to make the formula like this. Okay, plus this hydrogen is removed and giving us hydrogen gas. To make it balance, just place 2 with the propanoic acid. The equation is fully balanced. I hope you understand. Next, here he says that the propanoic acid can be formed from propane 1-ol and potassium dichromate. State the conditions required, because he is asking in a plural way, plural form, conditions. So what we gonna say that the potassium dichromate should be acidic and aqueous. So I'm going to write here potassium dichromate, potassium dichromate 6 should be aqueous and acidified. Aqueous and acidified plus heat, or again you can write heat under reflux. Here reflux is more important than the previous part. In previous form you may skip this, but here you must have to use this heat under reflux. Okay, this will confirm the complete oxidation, giving us the what? Alcohol, primary alcohol converted into the acid. Now he says complete the table 3.1, which is here. Show the number of sigma bonds that and the pi bonds present in the molecule X. So remember, X was propane nitrile. So this time I am trying to make a displayed formula so that you can easily understand what was propane nitrile. So this was how many carbon atoms? 3, and the third carbon atom is bonded with mean of a triple covalent bond with the nitrogen. So all other bonds are having hydrogen. So remember, whenever you find the single bonds, they are all sigma bonds. They are all sigma bonds. So how many sigma bonds we have? 1, 2, 3, this one 4, 5, 6, 7. And remember, in this triple bond, the initial bond is a sigma bond. So how many total sigma bonds we have? 8. The double and the triple bond, they are formed by the lateral overlap of unhybridized p orbital. So what we can say, how many pi bonds we have? Two. The one is the double and the other one is of the triple. So this one and this one, these two bonds are the what? Pi bonds. Okay, so the question completed here, and inshallah we will continue solving the rest of the question in our next video. Stay tuned, stay connected, and if you have any question, any query, do not hesitate, ask me in the comment section. Thank you very much. We'll see you in the next video.